how many y's we have. It's referring, right, to whatever variable or numbers in front of it. So let's look at another example. If I had 2 like this, what would this mean?
2x times
It means 2x times 2x. Why? Because this exponent here is referring to everything that's inside the parentheses. Okay, so that's really the only difference. And that's what I wanted to go over before we start the exploration. So if everybody can now take a look at the exploration guide.
So this not even a real lesson, it's just,
What do you mean real lesson?
because we just went over 2 times x times x.
Huh?
Before we do a
Well, let me explain the worksheet. So here, the exploration activity, what I want you guys to do is I want you to work on discovering, right, what these rules are. Instead of me just telling you what the rules are, I want you to we're going to go through and we're going to do the activities that are on here so that you can start seeing the pattern yourself, right? Because hopefully that'll have a longing understanding than me telling you what the rules are and you trying to memorize them rather than seeing and trying to figure them out yourself. As you're doing that, I want you to come back and you're going to answer these questions. I'm going to leave them up on the board so that you can answer them, and then we're going to go through and talk about the patterns that you guys discovered. Okay? So what are you guys working on right now? Somebody raise your hand and tell me. Yes, so you're going to work on the exponents exploration sheet, right? And you're going to go and figure out what the rules are. What are the rules that apply to multiplying, right? Dividing, and raising a power to a power. Okay? So we're going to look at the patterns. It's all in here, so we're going to discover the patterns. Okay? You can work in pairs. So if you want to move up, Renella, if you want to move up, or Delicia and Daryl. Okay? Alright, so I'm going to put the timer on the board. I'm going to give you guys about 15 minutes to complete this. Yes, ma'am? Huh? Hold on, let me look up. Let's start off by, guys, can somebody raise their hand and describe to me what was the rule, what was the rule we identified for multiplying exponents with the same base? Sorry, Colin.
When you multiply exponents with the same base, you join the 2 exponents and leave the base the same.
Okay,
You
so
add the 2 exponents.
So you add the 2 exponents and you leave the base the same. Can you write on the board the rule that you came up with for us, please? Thank you. So you can write it right here. Yeah, so that's the wrong question, sorry. Just write above it. Disagree here. Do we agree with this statement? Is this rule correct?
No.
What should be multiplication?
The base.
The left side.
Over here, right, we're multiplying, right? So this operation here, we're not adding them. We're multiplying. Okay? So I want to make sure we get that right.
But
So it's AB times AC, right? If we look at here at this example, we can see that what are they doing? They're multiplying the bases.
So
Okay?
how do you multiply
Base.
exponents?
We're not multiplying the exponents, we're adding the exponents.
Oh,
Right?
I'm saying because it said explain the rule for multiplying
Miss
exponents. Oh, never mind.
Miss Andrews.
Yes.
Say if we was adding those 2, what would we have to do with that one thing?
Okay, so if I have, and we've done this before, what would this be?
X to the 6.
What that?
X to the 6.
What does this mean? It means x times x plus x is x times x. So can I combine those?
Yeah.
Are they like terms?
Yeah.
They're like terms? Alright, let's look. I'll give you guys another example so that you can see. I think we're not seeing it.
What, 6x?
If I have, and we did this with polynomials before, if you have, what would you guys tell me that equals?
X, 2x to
3x.
Are they like terms? Can we
No.
combine them?
No.
They're not the same.
Because of the
These-
exponent.
Yeah, it doesn't have the same exponent. So can I combine these? No, this is addition, right? Remember when we're adding, we can only add things that are the same, right? I can add x plus x. That gives me what? 2x. Why? Because they have the same exponent. So I can combine those. I cannot combine these because these are not the same. Okay? So if this was addition, I wouldn't be able to combine them. Why? Because they don't have the same exponent. They're not like terms.
So you just leave it alone if you can't combine it.
If you can't combine them, right, it's simplified, right? When whenever they ask you to simplify, if you can't simplify any further, then you can't. Okay? Alright, so how would you explain the rule for raising a power to a power? Who wants to do that one for me? I want to hear it verbally and then write the expression for me. So somebody who can describe raising a power to a power, which question is referring to? What table is that referring to?
4.
That's 4, right? So that's what we did for number 4. So if somebody can describe the rule that we found, raising a power to a power plus you can. Okay, so Lacey, can you describe what you wrote for me? Come on, go ahead.
The exponent inside the rest of the table.
It's not here, it's on the bottom. I don't want to lose the question.
The exponent inside the parentheses is being multiplied by the exponent outside the parentheses.
So the exponent, she said, the exponent inside the parentheses is being multiplied by the exponent on the outside. Can you show us the rule that you came up with? Okay, it's a little hard to see, so I'm just going to trace it over. Or actually, I'll write it over here. She wrote x, y, to the t, right, equals x, y times t. Anybody disagree or agree with this? Anybody who disagrees? All right, somebody who agrees, explain why that is true. Somebody besides Calvin.
It looked like mine.
Okay, why? What's similar about it? Some of you guys, you didn't use the same variables, right? But why is it still true, even though it's different variables? Why is it still the same thing as what you found? Because what does it matter? The variables, right? These are insignificant. They just represent a number. So I could have used D, I could have used whatever I wanted, right? Still represents the same thing. What is it telling me? It's telling me that I'm multiplying these two exponents. Okay? Alright, so we have, how did you explain the rule for dividing exponents? What table are we referring to for that one? We're referring to table number 7. Can I have someone, Shanae, describe the rule that you found for that one?
You're subtracting your top exponent from the bottom.
And what did we notice about the base?
It's there.
What do you notice about the base? I'm going to bring the table up here. What do we notice about the base on this one? Here, she said that we subtracted, right? 5 over 3, and that gave me 2, right? But what about the base? The base is the same, okay? So I want to make sure we note that the base is the same. What they do right here, they can eliminate, right, the 2's on the top and bottom, and they're left with 2, which means that the shortcut here would be to subtract it. Can you write the rule that you found for us? You can write it over here, but it's a little more room. Awesome, thank you. So, is this a rule that we could apply every single time?